All right, thank you. All right, so today we're talking about calculating pH and calculating pOH. And we can also, from these calculations, calculate concentration. Now, remember I told you that the worksheets that you have might be a little bit different, but still we can work through some problems, and you can see kind of how you're supposed to use the formulas. And know what mode you need to be in your calculator. This is all based on acid-base theory. So according to acid-base theory, if I was to take the pH of a solution and add it to the pOH of a solution, it would theoretically equal 14. Where have we seen that number 14? From the pH scale, right? What is the range of the pH scale? Remind me. 0 to 14, not 1 to 14. 0 to 14. Okay. So, in this worksheet, we have it's just a chart with a whole bunch of blank spaces. Each row is supposed to represent one solution. And so theoretically, we can calculate the pH, the concentration of hydronium ions, which is also hydrogen ions. That's the second column there. We can calculate pOH and then calculate the concentration of hydroxide ions and then determine whether it's an acid or a base. So I'm going to give you the formula for each column, tell you what mode you need to be in, and then we're going to work some of those out. So for pH, it's going to be this column right here, and this is not going to, I can already tell it's not going to come out right. This is going to be too crazy. Okay, are you with me so far? Yes. To calculate for pH, there are two formulas. There are two formulas I can use to calculate for pH. First of all, I need to be in flow mode. You need to be in flow in your calculator.
How do you change mode again? Second degree, right?
Second, you press the blue button second, and then DRG. It's the button right next to it.
It says there's DEG, RAD, and G.
No, you didn't press the second first. You need to press second, DRG. Okay.
I know you're not allowed that. Push second, the blue button, and then DRG.
Okay.
The two formulas we can use to calculate for pH are this. The first one is pH equals, and we're just going to rearrange this top formula that I wrote right above it. How would we rearrange the top formula to calculate for pH?
pOH minus 14.
Try again. 14 minus pOH. So in order to use that formula, you would have to know the pOH to do that. Let's take a look. Let's take a look at the third one. Okay, so here we see that let's see, is it gonna, oh, come on. Here we go. They added all these new features, so I'm sorry. That's gracious. Okay. We see in the third row, the pOH equals 3.17. So we can do 14 minus 3.17, and what would we get? 10 point what? 10.83. I don't know if I want to write that because it's not going to box it together. 10.83. All right. Now, if we don't know if we don't know what the pOH is, the second formula we can use to calculate for pH is using the concentration of hydrogen ions. So the second formula, pH equals negative log times the concentration of hydrogen ions, or hydronium ions. It doesn't really matter how you want to look at it. And I'm sorry, my handwriting's not great, but pH equals negative log times the concentration of hydronium ions, or hydrogen ions. So let's take a look at the second row there. In the second row, we see that the concentration of hydronium ions, it's the second column, is 4.8 times 10 to the negative fourth, has a molarity. That M stands for molarity, right? We're looking at concentration. So in your calculator, and I know I'm recording, so those of you can't see if you're watching this, but in your calculator, you're going to do negative log, and the log button is the button right below the blue button at the top. You see it? Okay, negative log, and we're going to do 4.8 second E. Remember whenever we did the times 10 to the whatever? Do second E negative 4. So right now in your calculator, you should see negative log 4.8 E minus 4. You see it? Press enter. What is the pH that you see? 3.3, and what would we round that to? 2. 3.32 would be our pH. Hang on, I'll come around and I will look and make sure that you know how to put that in your calculator right. 3.32 pH. All right, so our pH that we calculated was 3.32. So those are the two different formulas we can use to calculate for pH. We can either do pH equals 14 minus the pOH, or we can do negative log times the concentration. All right, moving to the next column, we're going to look at the one formula there is to calculate for concentration. And again, I realize it says hydronium ion in there. The H3O plus is hydronium ion, but it's the same as calculating for hydrogen ion concentration. Okay, so the formula here, let's see. I can get this. To calculate for concentration, we're going to do concentration equals, and we saw this in our lab yesterday. What was the formula we used? Do you remember? 10 to the negative pH. Sometimes you'll hear it described as being inverse log. It's the same thing. In fact, there is an inverse log button on your calculator. Me personally, this is how I teach it. You can do it another way. It doesn't matter. Whatever is easier for you. I think this is the easiest way to do it. We're not going into, there's a whole study dedicated to understanding how they came up with these formulas to make these calculations. We're not getting into all of that. We're simply needing you to understand how to calculate for these things. That's it. In order to do this calculation, you need to be in scientific. You need to be in Sci. So go second DRG, scroll over to Sci, press enter. This is the only formula to calculate for concentration. So if your blank is, like, for example, let's take a look at number 1, the first row. Here we know that the pH is 3.58. We're going to calculate for how that translates into how many hydrogen ions I have that makes my solution have that pH. So we're going to do, make sure your calculator is in scientific. Otherwise, your number is going to be 0.0000000. Like, you'll get lost writing zeros. Yeah, I can't even calculate. Like, my eyesight's so bad, like, I can't even count. After the third zero, my eyeballs start going crooked. So you're going to go over to psi. You're going to put in your calculator 10, and I showed you the caret button. 10 caret, negative, and then for that first row, our pH is 3.58. So 10 caret negative 3.58. Enter. Now, we're doing concentration, and when we did molarity, what was our unit for molarity? M, big M. So we need to put that whole thing in there. Remember, we're talking about ions. So there's relatively speaking, we're dealing with this lots of numbers. So that's why it ends up coming out in scientific notation. So we're going to do, what are we going to write down? 2.63 times 10 to the negative 4. Oh boy. Sorry, guys. And this is M. 2.63 times 10 to the negative 4. That is my concentration of hydronium ions, or hydrogen ions. There's only that one formula. So if you don't know the pH, you can't start there. You got to start somewhere else. All right. Let's take a look at pOH. I guess I shouldn't have used so many different